This is a brief intro on how the model works. We will pass our images to MobileNet model, which will generate the feature vector for each image in our gallery. And then to find similar images, we will use those features. We will find cosine similarity between the image features, which will give us similarity scores, which is what we can use to search for images.
Here we have a basic home page, with just a material app which contains a scaffold. Currently this only displays the text, hello. Require the following packages. I'm having package issues with Photo Manager package, so I'm not using the latest version of it. Let's head back to main file, create an init state method to initialize variables at start. This cannot run async code. We can come around this by creating another method init packages that deals with all the async code and call it here. I don't want you guys to memorize all the code snippets for all the packages, so let's head to browser and search for Photo Manager Flutter pub. You will land in this page. You can find all the things that you need here. Scroll a little and you will find the permission request code snippet. Just copy this and paste it in the init package so that the permission is requested at the start of the application. You can use the get asset path list to get all the asset path entity. I want the paths variables to be accessible throughout the main function, so I am gonna declare it at the top. Let's now call the set state after the paths have been initialized so that it would update the UI. Let's print out the paths and see if it's working. Okay, we can see the values being printed on the console. Everything's working fine so far. Now let's create a new file called albums_gridview.dart. Create a stateful widget that returns a grid view builder. Here is a pro tip: use ChatGPT and other code completions LLMs out there to generate code snippets and skyrocket your development. I obviously didn't forget how to create a grid view. I was just trying to help you improve your development process. Now this will take the asset path entity list as its constructor. Update its item count using .length on the list. For better readability, let's make a function that returns the list item. The function takes the index and returns the corresponding album item in the grid view. And again, for the sake of simplicity, I'm just displaying the albums with their names instead of the images. Let's just save this and head back to the main file. The paths is initially null and they are fetched in an asynchronous manner, so we will create a condition that returns loading text if it is null, and the grid view if it's not. Let's just save this and move to the album grid view. Here let's add a gesture detector to the grid item. We are getting this syntax error here because this function has a return type of container, but we are returning a container that's wrapped in a gesture detector, so let's change its return type to just widget and then create the ontap. We will leave it empty for now. Let's create another file, image_gridview.dart, to display the images in the folder. Create a stateful widget which takes asset path entity. This should return a grid view. We will reuse the grid view code snippet from the previous file. Separate the grid item. This will help us keep the code clean. Update the item count. For this demo, I will only use the first 50 images. Now to load the images. Create a init image method that loads the first 50 images. Let's save them in entities. I want the entities to be accessible throughout the class. So let me just initialize it at the top and assign it here. After this we call the setState to update the UI. Call the initImages method in the init state. Initially the entities are null, so, if they are null, let's just display a loading text. If not, then we will display the grid view. Now update the initItem method to return images at that index. Oh no! I forgot how to load images. Never mind, ChatGPT got me covered. Let's copy and paste this code and ask it to modify it for images in a polite and respectful way. Now let's replace our method with the one here. The generated code won't just automatically integrate, so we have to stop being lazy and make some updates for it to work. The Unit 8 list is a missing import. In VS Code you can fix these by simply clicking on Control dot, which will show us the recommended fixes for the error. There is one more error here because of the return type. So let's change the return type to widget. Save this and move to the album grid view and call this whenever the user clicks on any album grid item. Save and run. So everything works fine. We want to have some buttons in the image screen. So we will wrap this screen in a scaffold. We pass the contents of a scaffold to its body instead of a child. Let's give it some padding by wrapping it in a container. Now add an app bar to the scaffold. We will place the buttons in the app bar. We will use row widget to place our two icons, one for generating embeddings and the other for printing of embeddings. Now we want some actions to be performed when clicked on those icons, so we will wrap those two icons in a gesture detector. Okay, they all are working fine. Our images here do nothing when we click them. We will wrap them in a gesture detector or inkwell, whichever to prefer to perform on click actions. I'm using inkwell now because it has some good visual effects when they are clicked on. We can print out the image names to see if they are working as intended. Okay, so the names are printed correctly. The basics are all completed. Now we will move on to dealing with TensorFlow models in Flutter. The models that I'm using is MobileNet v3 feature vector variant. Pay me $100 and I will share the link with you guys. Just kidding, I know that you are poor, bro, don't worry, I got you covered. The model is readily available on Kaggle in TF Lite format. The model takes images of 224 height and width with 3 channels and generates a feature vector containing 1024 features. Now we want to use this TF Lite model. Head to your browser, search for TF Lite Flutter Pub and open the first one. We have detailed step-by-step instructions on Flutter packages. To be honest, you don't even need this tutorial if you are smart enough. Everything is already available on the internet. Now things get even easier if you are using AI along with this. Subscribe to my YouTube channel if you want to be an independent developer like me, so that you can one day stop watching some random YouTube videos and build things on your own. Let's paste the TF Lite code snippets here. Paste the relative path to your model here. I want the interpreter available through this class, so I will declare it at the start of this class. And for you to be able to use any of the models or images or any other files, you have to first declare them in assets in the pub spec.yaml file. Now the models are ready to use. We will create a map raw embeddings and to store the embeddings temporarily. Create a method generate embeddings which will handle the input processing, embedding generation and storing of embeddings. I am not going to deal with the input preprocessing. I have generated this code snippet using ChatGPT. It looks complex at first, but the code is fairly simple. It loops over all the images in the list, extract the image data from the asset entity into forms that we can preprocess. Resize them to 224 height and width pixels with 3 channels. And lastly, it will scale those values between 0 and 1 by dividing the data with an int value which is 255. Let's print the input shape and see if it's returning correct inputs. Let's call this method in the generate embeddings method. As we can see that the input shape is in correct format. We can proceed to other steps now. Create an output list with the correct output shape. This will act as a placeholder for our outputs. The output embeddings contains 1024 features for each image. Correct the output shape mismatch error and then restart the application to remove the null reference error. Okay, as we can see that the predictions are printed correctly. We will now save the output embeddings in the raw embeddings map that we created. We will just use the file name as the key to its corresponding feature vector. So we are done with the ImageNet model. We will modify our images here, wrap them in a gesture detector or inkwell. Whenever the user clicks on the image, we will open a new screen with similar images in sorted order. Let's create a search_sort.dart file which returns the sorted images screen. This class takes list of asset entities, search vector, and the raw embeddings as its constructors. We will reuse the grid view from previous class. Let's copy this image item. Paste it here and modify the variable names. We are passing all the required variables to the constructor so we can just use them here. Now let's copy the grid view builder and paste it in the scaffold body. We will make a predict method and call it in the init state. Now this will run at the start of the screen. Load the model. I have already showed you how to load a TF Lite model. You can refer to the package documentation for all the code snippets. Our similarity search model takes 2 feature vectors and predicts its similarity score. So we will generate the inputs by looping through all the image feature vectors and stacking them with the search image vector. So input shape is supposed to be batch size x2 by 1024. Now let's push this add this screen in the onClick. Pass all the required parameters. Let me fix the type mismatch issue. We have to put this in a navigator.push. Now let's see if it works. There we can see the input data shape, which is what we expected. Now lead create the output placeholder and load the model. Let's make a new asset entity list which holds the sorted images. We will use this in the grid view to display the images. At the start of the screen we will just display images in their normal order, and later update them after the predictions. I have this sorting function that sorts the predicted values and returns the sorted indices. We are getting an error here. This is an updated code snippet that supports dynamic type. We will add those sorted assets in the sorted order and assign them to the images and call setState to update the screen. Higher score refers to higher similarity, so we have to reverse the sorted indices to get similar images.
Okay, so everything is working. This ends our video. I have these 2 video plans for my next video. Comment below on which one you would like me to upload. First one is about how to create your AI-based application by using any large language model. Second one is about how to create a chatbot AI agent that can respond to messages, identify users' requests, and perform relevant backend tasks. And if you like this video, I would like to ask you to check out my apps on Play Store. This is an AI-powered crypto prediction app where you can get crypto analysis, short and long-term predictions, and the app also includes demo trading feature that allow you to trade using demo currency. It comes with $250 demo currency which you can use to trade. I will provide the link in the description.